can see now what I just announced. Professor Mladen Berkovic was my advisor, together with Professor Homage. And I will start with prologue. What we can do today, basically using numerical simulation. You can see here, well, yet another secret. Something about research, but I try to explain something is wrong with font, obviously. This is a high temperature and pressurized turbine case. It is a very complex component from aeronautical field. You can see the geometry. I hope this will work. Yes, you can see geometry as it is. You can see a sketch with a crack. Actually, marks made by mistake, not to go into details, because in this secret code here, it's actually a reference to the paper in which all this is described. After defining thermal stresses due to temperature change and distribution, we were able to analyze this mark becoming a crack and to estimate the life with the aim to find out if this component is still usable or it has to be replaced. So without too many details, you can see here some of these aspects of numerical simulation. You can see crack, stress distribution, and the most interesting is, of course, how we simulate fatigue crack growth. So at our hands nowadays, we do have tools that enable us to make such a complex analysis, which is complex due to geometry, due to process itself. Fatigue crack growth, as you already heard, is still a kind of not completely investigated field. And then there is a material properties. I will not go into details, but maybe the main issue in these simulations that I am showing it as a prologue is how to determine material properties. By that, I mean relatively simple ones, coefficients in Paris law. So, yet another example in this prologue, yet another component from aeronautical problems. This is a critical component for landing gear, and both analyses were done by Professor Aleksandar Berkovic, who is now really an expert in analysis like this. Analyses are numerical, but we also never forget to emphasize that we do need experiments to verify our numerical analysis. Now here you can see, I will once again, you can see that at the first second or two, like now, nothing happens, and then crack initiates. So this is the latest option that ANSYS is offering, and that is to simulate the initiation phase of a crack. So we do not need to position and locate crack. Software itself will find the most stressed part, and then after a certain number of cycles, it will simulate further crack propagation after this period of crack initiation, which you cannot see actually. So that is something which is really, that we really could only dream of years ago and especially decades ago. So now I'm going back to history to explain how people like Mladen Berkovic enabled us to come to this. You can see some basic information about it. He was born in 1936, and back in late 60s and early 70s, he started working on the finite element method to apply it to multiple components, and thus he became involved also in computational fracture mechanics, which is the title of my presentation. History of finite element method in fracture mechanics starts with, well, whom else than Jim Rice? All important aspects of fracture mechanics, more or less, are initiated and in a way, in at least partly solved by Jim Rice. He is a living legend. On 3rd of December, he will celebrate his 84th birthday. Anyhow, after he did this first step, which is of course the most important, not much later on, Mladen Berkovic followed this work. So in ex-Yugoslavia, it was his thesis back in 1977 on isoparametric membrane element, which was the first breakthrough of finite element method in ex-Yugoslavia. And then he continued working on fracture mechanics. A bit later, but maybe almost the same time, academician Miloš Kojić established another, let's say, school of computational mechanics in ex-Yugoslavia, in Kragujevac. And I'm mentioning this especially because Miloš is a living legend also, and he is academician. That is the level of the research that was done also by Mladen. Now, a few slides with a couple of pages, actually content of Mladen's doctoral thesis. I will go fast, it's in Serbian, but just to emphasize that his approach was the basic one. He established computational mechanics and computational fracture mechanics. He started his research by using conservation laws and by adding other continuum mechanics laws and putting them together, then applying Rayleigh-Ritz and Galjorkin methods to discretize continuum, to introduce interpolation functions, and to get finite element method working, not only by putting and writing equations, but also by programming. He was one of the first, if not the first, in this region who had his own software developed. The high level of his thesis and high contribution of his thesis, one can see from the fact that it contains only 3 words. So, membrane finite elements. And it is due to the fact that he introduced these elements, not here, worldwide. Not only here. So it is all about the content. I can now say a few words about an event that happened 20 years ago on the occasion of his of 5 years of his untimely death. At that time, we had a special symposium, and at that time, we printed also a couple of papers that Mladen published based on presentations that he had during 80s and 90s in so-called international fracture mechanics summer schools. So a few words about that, and also a kind of urban legend how we met. In the year 1980, Professor Michael Nook was a guest of his sabbatical in Belgrade. He was a guest of Professor Mladen Sedmak, my late father. They worked together on fracture mechanics problems, and then sometime in April, maybe, Michael suggested that they could organize fracture mechanics summer school. That was in June. Those who still remember Michael, they understand that a proposal like that could come only from him, because it was 2 or 3 months to organize very important and demanding event. What made it demanding was to find kind of sponsor, and that was Gosha Industry, very powerful firm at that time. General Manager Tihomir Tosic. He provided everything that we needed. But to find 20 lecturers, which was kind of program, 10 from ex-Yugoslavia, 10 from the world, was not an easy task. So Stan was in charge for ex-Yugoslavia, Michael was in charge for the world. And Michael completed his task fast. He was very well connected. He was originally, by the way, from Poland. But Stan failed to provide a lecture on numerical methods in fracture mechanics. He told Michael, we don't have anybody in Yugoslavia, ex-Yugoslavia. Michael told him, yes, you do. And Stan was a bit surprised, not to say shocked. Today, everybody is shocked. So he was surprised. And Michael told Stan, it's Berkovic. Stan thought it's Berkovic. Stan told it's somebody from Israel or a Jew from somewhere. No, no, said Michael, no, Professor Mladen Berkovic from Belgrade, and he works with Military Institute. Actually, that was to find a couple of days later with the help of another fracture mechanics legend, Professor Dr. Aleksandar Sedmak. He was director at the time and also involved very much in all this, what I'm talking about. So the point is that we in Yugoslavia, Serbia, Belgrade, we did not know about Mladen, but he was world well known. 4 years before that time, he was one of 16 invited presenters for the first World Congress on Finite Element Methods, somewhere in UK. That was not completely open conference, that was conference with lecturers who were invited and then participants who were supposed to learn something very new. Also at that time, we met our living legend, Professor Joe Jaric, who joined us to complete polytrinity of fracture mechanics in ex-Yugoslavia and Southeast Europe, because my father, Mladen Sedmak, was in charge for experiments, Mladen Berkovic for numerical methods, and Joe Jaric for theoretical development of fraction mechanics. I fully understood Rice's J integral only after I had discussions and some other people in the famous zoology group with Professor Jo Jaric. And this approach, which we called conservation law of J integral type. So what was our lecture at the first 7 fraction mechanics summer schools? Another interesting fact is that actually he was the only one who was lectured at every single fraction mechanics summer school until 1996. So this, what is on the screen, is actually a tutorial that my father made on the occasion of 5 years after Mladen's death. So I have this as the last slide, but before that, I would like to show you also a couple of kind of screenshots. Those are papers which we published on that occasion, which are reprints translated actually into English of lectures presented in 1980, 1982, 1984, 1986, 1989, and 1992. The first one is the most important one: determination of stress intensity factors using finite element methods. This lecture is actually how I got involved in my future work. I was only 25 at the time, and I found out the beauty of finite element methods and the capabilities, which were very limited at that time, but nowadays are unlimited, it seems. That was the time that I decided what to do in my life. You can see here some basic equations. You can see here the establishment of whatever is built in the very powerful softwares that we use nowadays. I especially emphasize that we should know what these softwares are based on. Not to use them just as black boxes, but to understand their limits, although their capabilities nowadays are almost unlimited. Equation number 14 here is given in form of continuum mechanics. This is J integral, famous J integral along a certain path. The same equation is given later in this paper, in this form, and in this form it is already discretized. By using these two, by seeing these two equations, that was the first time I understood how finite element method actually works. So this paper is of utmost importance for my own career. Well, probably we can stop here. Other papers we might briefly see. The one from 1982, which was more general. It was focused on J integral. Also, it introduced, made for the first time, non-linearity. You can see once again all these equations and how to solve nonlinear problems. For a brief moment, I'll go back because I forgot to emphasize that even in his first paper, Mladen already established a way how to calculate structural life using Paris law as it is shown here as the initial equation, and then how to do it with finite element methods. 44 years ago, that was definitely completely new for all of us. 1984 was about problems of plane and triaxial states, something a bit similar to what Bojan Međa presented. Then there was very important paper on welded joints with relatively complex continuum mechanics. It was a coupled thermomechanical problem that was solved here. And maybe just one more, which was part of my doctoral thesis, conservation law of J integral type for tin shells, and this was the numerical part. So let me go back to presentation. Let us never forget what Mladen did for us. Thank you.